Our understanding of the universe grows as new hypotheses are developed, and what we formerly considered to be facts turn into myths. But because of space missions like Voyager, which expand our horizon into the unknown abyss, we have more conclusive ways of comprehending the cosmos. Everything changes when a significant space probe like Voyager returns information indicating fresh findings. The farthest distant spacecraft from Earth, Voyager 1, has discovered an incredible finding outside of our solar system. For those who don't know, the Voyager 1 spacecraft was launched by NASA in 1977 with the primary objective of exploring the outer solar system and interstellar space. Our view of the universe has changed as a result of the probe's insightful findings, which have been orbiting the Sun for almost 46 years. The latest astounding findings made by Voyager 1 outside of our solar system has the scientific community both excited and perplexed. So let's dive into the details and find out what Voyager 1 has discovered. Consequently, what are the odd communications coming from Voyager 1 coming from the depths of space? Is there any need to worry or not? You will get to know this and plenty more as we dive into the details of today's video. However, before getting started with the video officially, here's a quick reminder that you can subscribe for free and like the video so that we can boost the algorithm. Comments are most welcomed. The era of space exploration. 1965 marked the beginning of an era of space exploration because it was just 8 years since the Soviet Union had launched Sputnik 1, the first artificial satellite. Flandro, a part-time employee at NASA's Jet Propulsion Laboratory in Pasadena, California, was in charge of devising the most efficient way to launch a space mission to Jupiter, or perhaps even out into Saturn, Uranus, or Neptune. Using a pencil, a preferred precise tool of 20th century engineers, he charted the orbital paths of those giant planets and made the astounding revelation that in the late 1970s and early 1980s, all four will be strung together in a long arc with Earth-like pearls and a necklace. The spacecraft might accelerate as a result of this coincidence, gaining speed from the gravitational attraction of each huge planet it's passed. It would be as if an invisible rope was pulling the probe along, but it would abruptly snap, sending the probe flying on its route. Flandro predicted that the regular gravity assistance will result in a reduction in the travel time between Earth and Neptune from 30 years to 12 years. Despite the alignment only occurring once every 176 years, there was one downside. By the middle of the 1970s, a spacecraft would have to be launched in order to reach the planets while the lineup was still in force. As a result, Voyagers 1 and 2 were built, a historic voyage. In 1977, Voyager 1 and Voyager 2 both departed from Earth. They weren't the first spacecraft to arrive at the closest of the large planets. Pioneers 10 and 11 held that distinction. The Voyagers made some amazing discoveries while being more advanced than the Pioneers. Io, a beautiful moon of Jupiter, was found to have volcanoes by Voyager 1, which reached Jupiter earlier and traveled less distance than Voyager 2. The first nitrogen atmosphere discovered outside of Earth was found close to Titan by Voyager 1 when it approached Saturn in 1980, studying the complex intricacies of the rings. Voyager 2, which stopped at Jupiter, Saturn in 1979 and 1981 respectively, before traveling by Uranus and Neptune in 1986 and 1989, took a more stunning route. After that, the spacecraft began to proceed in the direction of other stars. According to astronomers, the solar wind, the sun's discharge of charged particles, ends at the point where the interstellar medium begins. Similar to a stone blocking a stream, this ionized gas or plasma pushes against the cooler, denser galactic plasma flowing around it. Similar to how tropopause is used to describe the top of the troposphere on Earth, the terms heliosphere and heliopause are used to describe the hole made by the Sun. According to Don Gurnett, a Voyager researcher at the University of Iowa in Iowa City, we really didn't know how far out the heliopause was at the time Voyager was launched. It has been proposed that the heliopause is 5 times closer to Jupiter or even to Earth than it is to the Sun. On August 25, 2012, Voyager 1 eventually accomplished its goal, as Gurnett had projected 20 years earlier at a distance of 121.6 astronomical units, or roughly 4 times the distance to Neptune. Nonetheless, there was such a heated debate about the crossing that it took NASA an extra 13 months to declare it a success. Yet, Voyager 1 did find some evidence that it had passed the heliopause. The high-energy solar wind particles vanished, which implies that the remaining solar wind was also left behind. In addition, once Voyager passed by, cosmic rays from the outside of the solar system, which the heliosphere partially deflected, became more intense. 2 issues were present. Voyager 1's plasma instrument had a problem, thus it was unable to capture the increase in particle density that happened when the spacecraft left the heliosphere and entered interstellar space. Second, the magnetic field outside the heliosphere did not point in a different direction as was predicted. Crimigus argued that nature just wasn't aware that the magnetic field direction was intended to be altered because it hadn't read the theorist's papers. Why the magnetic fields inside and outside the heliosphere coincide is still a mystery. The Sun helped make Voyager a success. Solar storms that had earlier broken out astonished Voyager 1 as it sped through plasma, causing electrons to vibrate and produce radio waves that the spacecraft recorded. These radio waves' frequencies were measured, and the results showed that Voyager had actually entered a zone that was much denser, the boundary to home. This puzzle needs to be investigated, and using information from Voyager and other findings, researchers must provide an answer. During the previous decade, both spacecraft penetrated the interstellar medium, the thin substance that fills the vast space between the stars, entering a new domain. There, the spaceship continuously picks up fresh knowledge. The interstellar magnetic field's strength and direction have astounded researchers, and the new data has even sparked a dispute about the shape and activity of the heliosphere, the Sun's magnetic field. Is the heliosphere more spherical than a long-held belief that it is a comet-shaped structure? And does its size fluctuate with the number of sunspots, or is it more stable? The spacecraft has given some tantalizing insights. The hypothesis that heliopause changes is not new. Researchers have examined data from numerous sources over the last 10 years to comprehend its dynamic character, with the help of NASA's Interstellar Boundary Explorer IBEX satellite, which monitors energetic neutral atom emissions. This boundary's location and behavior have been better understood. Voyager 1 and Voyager 2 were the only spacecraft to depart the heliosphere. The Voyager probe only sent direct observations at a certain point in space and time. IBEX added more context to their data to complete them. With this knowledge, scientists have constructed models that forecast how their heliopause may change in the future. In contrast to the solar winds and interstellar medium, which push and pull against one another, the heliopause is a boundary that is constantly moving. However, data from more recent heliopause investigations refutes earlier conclusions. For instance, the IBEX satellite discovered that the 2014 brightening of energetic neutral atoms, ENAs, which at first suggested asymmetry in the heliopause over a period of months, was incompatible with the models as they are now written. The heliopause appears to have moved dramatically in a short period of time, according to the data from Voyager 1 and 2 spacecraft, which may help to explain the enormous time difference between the entry of the two probes into interstellar space in 2012 and 2018 respectively. Yet, the heliopause changes, calling into question theories put forth to explain its stability. The results of the investigation were described in a paper that was released on October 10th. They believed that these disparities were intriguing and possibly even provocative. NASA's Interstellar Mapping and Acceleration Probe, a new and better satellite that will launch in 2025, will be able to detect ENAs, is expected to help scientists learn more about heliopause. It is yet unknown what is generating the heliopause's unexpected behavior. Voyager 1's Attitude Articulation and Control System, or AACS, started transmitting jumbled data in May of this year instead of the regular updates on the condition and health of the spacecraft. The high-gain antenna is continuously directed at Earth by the AACS. This behavior is similar to electronic aphasia, a condition that makes speech difficult to understand. Another intriguing study that needs more details to be completely grasped. It's possible that the data weren't carefully chosen or don't accurately reflect the spacecraft's current condition. The engineers were baffled by the fact that updates from spacecraft Voyager 1 looked to be in good form despite the peculiar circumstance. Even though NASA had stated at the time that its AACS may have been in an aberrant state, the ship's radio communications were still strong and steady, indicating that the antenna was still directed toward Earth and not where the AACS said it was. Notwithstanding the AACS' peculiar behavior, Voyager 1 science systems are nevertheless collecting and transmitting data as usual. Whatever the problem with the AACS was, it didn't make it such that a fault prevention system, which would have put the spaceship into safe mode in the case of a malfunction, would have been activated. Fortunately, NASA specialists were able to locate and fix the issue. It was revealed after the command to the AACS was delivered that the AACS had started broadcasting its telemetry data using an onboard computer that had long since broken, resulting in the data being jumbled. Finding the root cause of the AACS's choice of switching systems will be the next difficult task. NASA speculates that a different onboard computer may have given the system the wrong instruction. Voyager 1's health is thought to not be in immediate danger, but in order to stop subsequent worries, the main source of this problem needs to be identified and rectified. The magnetic field of the Sun, which had previously protected Voyager 1 from cosmic rays and other types of interstellar radiation, has been left behind as the spacecraft has been traversing interstellar space for the past 10 years. Similar to how the Earth's magnetic field shields people from solar radiation and high-energy particles. Without this protection, it is likely that the onboard computer circuits of Voyager 1 are experiencing memory problems due to the high-speed energetic particles. Notwithstanding these challenges, the Voyager 1 mission is still in operation more than 45 years after it was built. This has flown us to the end of this historic odyssey. When do you expect Voyager 2 to cross the boundary of our solar system? Do let us know in the comments section below. If you enjoyed this video, please hit that thumbs up. It will help us to understand our audience and allows YouTube to suggest similar videos to you. Thanks for watching, and we hope to see you at the next one.